What if the universe was not silent, but leaving behind visitors that pass through our cosmic neighborhood without warning? In October of 2017, the Pan-STARRS Observatory in Hawaii caught sight of something extraordinary. A faint point of light, moving across the sky, small yet impossibly fast. Astronomers quickly calculated its path, and what they found defied everything they had known. This object was not bound by the gravity of our sun. Its trajectory revealed that it came from beyond the solar system, making it the very first confirmed interstellar traveler ever observed. The object was named Oumuamua, a Hawaiian word meaning scout or messenger from afar. Its speed, its unusual motion, even its elongated shape sparked debate across the world of science. Shock, awe, and disbelief rippled through astronomy. Some called it a fragment of a shattered world. Others wondered if it was something far stranger. 2 years later, in 2019, another visitor arrived. This time, unmistakably a comet, shedding gas and dust in a glowing tail. It was called Borisov, and it confirmed what Oumuamua had hinted at. The galaxy was sending travelers, fragments of distant systems, slipping into our skies like letters delivered across the void. Then came 3I, later named Atlas. Detected by the Asteroid Terrestrial Impact Last Alert System in 2019, it carried the same unmistakable signature. Not of this system, not born beneath our sun, but a traveler from beyond. Astronomers gathered early observations, comparing it instantly with the first messenger. Could this be another fragment of alien worlds, or a new mystery entirely? Each discovery deepened the question. How many visitors are still out there racing silently through the dark, waiting for us to notice? When Oumuamua first swept through the solar system, its strangeness was not immediately clear. At first, it was simply a faint streak of light, a small visitor tracked against the darkness by telescopes in Hawaii. But as data poured in, a deeper unease began to stir within the halls of science. For this was not an ordinary rock, not a wandering comet, not a frozen relic of our own system. Its behavior, its shape, and its motion seemed to whisper of something. Alien to both Earth and Sun, astronomers expected a comet. An icy body cast away from some distant star, a traveler that should shed gas and dust as it warmed in the sun's light. Yet Oumuamua did no such thing. No faint tail, no glowing halo, no whisper of water vapor appeared. The object was dry, silent, and smooth, like a shard of stone drifting across eternity. Still, its trajectory told another story. It was accelerating as though pushed by something unseen, a slight but measurable force nudging it faster than the laws of gravity alone would allow here. The mystery deepened. A comet gains speed when gas is trapped within its ice vaporize, venting jets that act like tiny thrusters. But Oumuamua showed no sign of such activity. Its surface reflected light, in ways that made even its shape uncertain. Some models suggested a cigar-like geometry, elongated and tumbling end over end like a baton tossed into the void. Others painted an entirely different picture, a flattened, pancake-like worldlet, skimming through space like a shard of cosmic glass. In either case, no natural process known to science could easily explain the combination of geometry, motion, and silence. The object rotated chaotically, completing a tumble every 8 hours. The way its brightness changed revealed surfaces broad yet thin, catching sunlight and reflecting it with an odd consistency. Could it be that solar radiation itself, the faint pressure of photons streaming from the sun, was enough to account for its acceleration? If so, then Oumuamua was not merely rock. It was something far lighter, perhaps a sheet-like fragment, thin as foil. Spread across dozens of meters, that the implication unsettled even the most cautious voices. If such an object was truly that thin, natural explanations faltered. How could cosmic collisions or planetary birth forge such fragile architecture? It was then that one possibility, long the province of fiction, entered serious scientific debate. Could Oumuamua be artificial? The suggestion was not made lightly. Avi Loeb of Harvard University put forth the hypothesis that the object might be a probe or a fragment of technology left adrift by another civilization. His reasoning was not based on fantasy, but on elimination. When all conventional mechanisms failed to explain the data, what remained demanded attention. A solar sail, perhaps carried across interstellar space, nudged along by starlight. Proof of extraterrestrial craft. But a reminder that the universe may hold architectures beyond our imagination. Other astronomers countered with caution. Natural explanations, though strained, remained possible. Oumuamua might be a fragment of nitrogen ice, chipped from the crust of a Pluto-like world. As it warmed, invisible gases could escape in a way too faint for our instruments to detect. Or it could be a fractal body, porous like pumice, so lightweight that even sunlight alone could move it. The arguments multiplied, each theory reflecting the discomfort of minds confronted with data they could not yet resolve. Yet, the true shock did not come from its shape or its silence. It came from the realization that such an object had found its way here at all. For billions of years, the solar system spun quietly, and humanity assumed that interstellar debris, if it existed, would be rare beyond measure.
Then came Oumuamua.
And only 2 years later, a comet so clearly interstellar that its foreign composition glowed in spectrographic readings. And then, not long after, 3 IATLAs appeared. 3 messengers, each distinct, yet united by the fact that they were not born of our sun. If 3 arrived in just a handful of years, what did that mean for the cosmos? The probability shifted. Interstellar wanderers were not rare. They were common, perhaps unimaginably common. Billions of such fragments could be drifting unseen between the stars, each one carrying the history of worlds we will never touch. The solar system is not an isolated stage, but a crossroads where foreign travelers pass regularly. Most escape our notice, slipping through like shadows cast on water. This realization struck astronomy with profound force. It was not simply that Oumuamua was strange. It was that the universe had been delivering these visitors all along, and only now did we possess the eyes to see them. Telescopes like Pan-STARRS and surveys like Atlas widened our vision, revealing that the dark is not empty, but alive with movement. Every year, countless messengers may thread through our skies, carrying secrets of alien chemistry, alien geology, perhaps even alien biology in frozen, dormant forms. For scientists, the shock was twofold. First, the strangeness of Oumuamua itself. Second, the dawning awareness that such strangeness might not be isolated at all. If interstellar debris is abundant, then the mystery is not why we saw Oumuamua. The mystery is why it took so long to notice. From this realization grew speculation of staggering scope. Some envisioned a galaxy filled with wandering shards, the wreckage of planets torn apart, the remnants of stars consumed, the building blocks of future solar systems adrift. Others imagined still stranger cargo, fragments of technology lost. Probes, or ancient sails no longer guided by intelligence, but still drifting. Like relics of civilizations long gone, theories blossomed in every direction, yet each shared a single theme. Humanity had crossed a threshold. No longer could it be said that interstellar visitors were the stuff of theory alone. They were here, they were real, and they were passing through in plain sight. Oumuamua became more than an object. A symbol, a mirror held up to our assumptions, showing us how little we had known about the pathways between stars. The shock it delivered to science was not only intellectual, it was existential. To look upon a shard that had traveled for millions, perhaps billions of years, was to confront time and distance on scales that dwarf human meaning. Its very presence asks questions we are only beginning to form. What else drifts between the stars? How many worlds have been shattered to cast such fragments into the void? And could some of these messengers carry more than dust and stone? Could they carry the whispers of life itself, scattered like seeds across the galaxy? The scientific shock of Oumuamua was not in its answers, but in its questions. Tore open the sky and revealed that the cosmos is not a closed system. It is a river of matter, flowing endlessly, with Earth and Sun merely one eddy within it. The appearance of Three-Eye Atlas only deepened the truth. This was not chance. This was not a rare alignment of cosmic luck. This was normal. Interstellar objects are common. Perhaps countless billions roam unseen. Each discovery adds weight to the idea that our solar system is part of a living network, an exchange not of communication, but of matter itself. Debris from alien shores arrives here, and perhaps one day, fragments of our world will drift outward, carrying pieces of Earth into distant systems, long after our species is gone. For astronomers, the moment of shock has passed into a new era of pursuit. New surveys rise. New instruments prepare to scan the heavens with greater sensitivity. The hope is to catch the next messenger sooner, to track it closer, to measure it in greater detail before it escapes again into the dark. Because if Oumuamua was strange, it may only be the first whisper in a chorus of mysteries yet to arrive. The scientific shock lingers still, not as confusion, but as anticipation. Humanity now knows that the stars send us visitors. The next one may bring revelations beyond anything Oumuamua could provide. The first sighting of Oumuamua had left astronomy reeling, but the true work began only after the initial shock. Scientists turned every tool they could toward the faint traveler. They asked not simply what it was, but what story it carried. Within its strange motion, its flickering light, its stubborn silence in the face of expectation. From the very beginning, brightness itself became a language. As Oumuamua tumbled through space, its reflected sunlight rose and fell in patterns that spoke of its shape. No telescope could resolve the object directly, so it remained a point of light. Yet in the rhythm of its flicker, clues emerged. Sometimes its glow brightened tenfold, then dimmed, then brightened again, every 8 hours. The implication was staggering. Such variations suggested a body elongated or flattened, rotating chaotically, never steady, never calm. Unlike the well-behaved spin of most asteroids, this one wobbled like a bottle set, adrift in waves. That tumbling raised more questions than it answered. Had it been thrown into chaos by a violent collision long before it entered our solar system? Was it a fragment of something shattered, the piece of a larger body lost in interstellar exile? Or was its rotation somehow linked to the unexplained acceleration that carried it slightly faster than gravity predicted? Each new clue added layers to the mystery rather than unraveling it. To probe deeper, astronomers turned to the most sensitive eyes humanity has ever built. The Hubble Space Telescope tracked the visitor as it receded into the distance. Measuring its fading light with precision, no ground-based observatory could match. Pan-stars, which had first detected it, continued to refine its path, mapping the object's strange course with data stitched across nights. On mountaintops in Chile and Spain, the European Southern Observatory aimed its instruments skyward. Spectrographs split the faint light into rainbows, hoping for signatures of chemical composition. But the spectra revealed almost nothing. Emission lines of escaping gas, no familiar fingerprints of water or carbon dioxide that comets so readily display. Oumuamua remained an enigma. As months passed, astronomers realized that they were chasing a vanishing phantom. By the time of its discovery, Oumuamua was already speeding away, racing outward at nearly 95,000 kilometers per hour. No spacecraft could catch it, no second chance to see it up close. All that remained was light and the careful interpretation of its subtle variations. From that flickering point, they built models, simulations, and hypotheses. Some imagined a shard of rock, cigar-shaped, tumbling lengthwise. Others leaned toward a disc-like form as flat as a pancake, spinning in unpredictable rhythms. None could explain why the object accelerated away from the sun, without leaving a visible trace of venting gas. The deeper they looked, the stranger the patterns became. The acceleration was real, measured again and again with high confidence. Yet it refused to fit the established physics of comets. For comets, sublimation of ice acts like tiny rocket engines, pushing them outward. But Oumuamua bore no halo. No jets, no tails, no cometary breath. If solar radiation alone had nudged it, then it must have been incredibly light, perhaps only millimeters thick. Like a sail stretched across space, Such an idea hovered uncomfortably at the edge of plausibility. Could natural processes produce such thin fragments, sheets of material drifting for millions of years without disintegrating? Or did this possibility hint at something more unsettling, the possibility of design? While scientists debated, the universe offered another clue. In 2019, a second interstellar traveler announced itself. This one, named Borisov, blazed unmistakably as a comet. Its tail streamed behind it, and its gases bore chemical fingerprints that spoke of a chemistry familiar yet foreign. Lines revealed water, carbon monoxide, and cyanide, the building blocks expected of icy worlds, but in abundances unlike those of our own system. Borisov was the control case, the confirmation that not all interstellar messengers are so inscrutable. Some arrive in forms we know, yet altered by the environments of distant suns. And then came 3I. Christened Atlas, detected by the asteroid Terrestrial Impact Last Alert System. It traveled on an orbit that screamed of interstellar birth. Its speed, its path, its openness to the galaxy beyond, all of it marked it as foreign. Early observations hinted at comet-like behavior, though its brightness fluctuated in ways that puzzled astronomers. Spectrographs searched for its chemical story, straining against distance and faintness, trying to tease out the fingerprints of elements and molecules. Taken together, these messengers began to form a pattern. They were not bound to the expectations set by the asteroids and comets of our home. Instead, they spoke of diversity, of differences shaped by alien conditions. Some were icy, some dry. Some blazed with activity, others whispered silently past. Their very presence suggested that planetary systems across the galaxy were not isolated islands. They shed material, they scattered fragments, and those fragments roamed free until chance brought them here. To the human imagination, the implications were profound. Every shard could be a clue to a lost world. Oumuamua might be the broken tip of a planetesimal, a rock once locked within the crust of a world that circled a distant star. Borisov's icy body might be the remnant of an alien comet belt, shattered and dispersed when its parent star stirred the orbits of countless frozen wanderers. Atlas II might be a piece of planetary debris, orphaned long before our sun was born. Yet the questions multiplied faster than answers could come. Could these objects be the cosmic equivalent of fossils, carrying within them the deep time of alien systems? Could they even, in the most daring speculation, be artifacts, relics of technologies built by civilizations whose traces have long since faded? The thought was unsettling, but it was no longer dismissed out of hand. If interstellar objects can be as thin as sails, if their motion can defy expectations, then they cannot be so easily confined to the familiar. The deeper investigations continued long after Oumuamua had vanished from view. Computers modeled its motion with exquisite care, adjusting for every gravitational tug, every possible sublimation scenario. Observatories scoured the skies for its successors, hoping to catch the next messenger sooner, before it slipped too far away. The discoveries of Borisov and ATLAs proved that Oumuamua was not a solitary oddity. It was the first voice in a chorus that, with each new detection, grew louder, reshaping the scientific understanding of what fills the dark between stars. What these surveys revealed was a new category of celestial object, not asteroid, not comet, but interstellar. Visitors from beyond the sun's family, each with a story written in its structure and motion. And through them, a new vision of the galaxy emerged. The Milky Way is not a quiet place. It's restless. Its planetary systems cast off fragments endlessly like sparks from a fire, and those sparks drift outward across billions of years. Our solar system is not closed but porous, open to encounters that connect it to histories unimaginably far away. The instruments that traced these discoveries, Hubble, Star's Atlas, the telescopes of ESO, became more than machines. They became the senses of humanity reaching beyond its cradle, straining to hear whispers carried across interstellar seas. Each measurement, each spectrum, each faint detection was a thread of connection, tying Earth to the larger story of the galaxy. And yet, for all the data gathered, The questions only grew heavier. If these are mere fragments of alien geology, what cataclysms flung them into the void? Are they shards of shattered planets, relics of collisions, as violent as the one that formed our own moon? Or are they routine debris, scattered during the chaotic birth of planetary systems, when gravity sculpted order from chaos? And if some are not natural at all, if any hint of artifice lingers in their form, then the implications are far greater. They would be evidence not of chance, but of intention. Proof that intelligence is not confined to Earth, but that civilizations may once have reached out across the void, leaving behind objects that still wander long after their makers have vanished. The investigations continue, driven by the hunger to know. The Vera C. Rubin Observatory, soon to scan the entire southern sky night after night, promises to expand the search exponentially. Where today only 3 interstellar visitors have been confirmed, tomorrow there may be dozens, then hundreds. Each will carry its own peculiarities, its own mysteries, its own chance to rewrite what we believe about the galaxy, in the flicker of brightness. In the silence of spectra, in the faint tug of unexplained acceleration, humanity is learning that the universe is not a gallery of distant stars alone. It is also a sea of travelers, messengers without number, each passing through like a note in a cosmic symphony. And we, with our fragile instruments, are only now beginning to listen. The deeper the investigations reach, the more profound the reflection becomes. Are these simply stones, lost and wandering? Or are they the fragments of planetary systems that rose and fell before Earth ever existed? Could they be the accidental debris of alien technologies, shattered sails and probes that drift long after their purpose has been forgotten? In the end, the instruments reveal only pieces of truth. Shapes inferred from brightness, speeds measured against gravity, chemistries hinted at in spectra. From these fragments, humanity builds meaning, stitching together narratives as fragile as the data itself, but the questions remain. They multiply like stars seen deeper and deeper into the night. What is truly passing through our skies? Planetary debris, ancient and silent, or something more, carrying messages we are not yet ready to understand? When Oumuamua first streaked through the solar system in 2017, it felt like a singular event, a once-in-a-lifetime discovery, the first confirmed interstellar traveler ever seen. Yet just 2 years later came Borisov, its icy tail blazing proof that other systems, too, cast off wandering comets. And before that wonder could fade, 3 IATLAs appeared on the stage. 3 visitors in such a short cosmic heartbeat. The implications were startling. The first could be dismissed as chance. The second, as confirmation. But the third was escalation. Suddenly, the image of a quiet, isolated solar system dissolved. Earth was not nestled in silence, drifted instead through a galactic sea alive with wanderers. The space between stars was not empty, but thick with objects adrift, shards of planetary birth, relics of ancient collisions, frozen comets torn from orbits that once circled suns long extinguished. Astronomers began to grasp the scale. If 3 had been detected in just a handful of years, how many more must pass unnoticed? Instruments like Pan-STARRS and Atlas, sweeping the skies with automated precision, had only recently grown powerful enough to catch them. Before, such objects would have slipped silently past, unmarked in the vastness. The realization spread like a ripple across the scientific world. The galaxy was littered with debris. Our solar system was no sanctuary. 3 IATLAS itself carried mysteries that deepened the puzzle. It behaved like a comet, glowing faintly, with signs of sublimation. Yet its path bore the unmistakable stamp of interstellar origin, its velocity relative to the sun, its hyperbolic trajectory, all spoke of a birthplace beyond. Early spectrographs hinted at composition, elements both familiar and strange. It was not alien in the sense of incomprehensible, but alien in origin, shaped by a star we will likely never see. In a system whose story we can only imagine, together, Oumuamua, Borisov, and Atlas formed a pattern. And patterns demand explanation. Were these fragments the normal detritus of galactic evolution, the inevitable waste of planetary formation? Or were they the remnants of catastrophic events? Planets ripped apart, systems destabilized, ancient wreckage strewn into interstellar night. The thought grew unsettling. Perhaps the messengers that pass through our skies are not peaceful, wanderers at all, but the ashes of worlds that came before. This escalation of discoveries reshaped hypotheses. Some scientists propose that billions of such objects drift through the galaxy at any moment, invisible until they happen to pass near a star bright enough to reveal them. Others wondered if many more could be small, too faint to detect, streaming through the solar system in swarms. If so, then Earth does not live in quiet isolation but in constant intersection with relics of other suns. Every year, thousands may brush past unseen, while a rare few are large enough for our telescopes to catch. From this came darker speculation. If these messengers are planetary shards, what histories do they carry? Could they include material hurled outward by cosmic catastrophes, worlds torn apart by collisions, atmospheres stripped by supernova, surfaces scarred by radiation so intense that their very chemistry bears the mark of destruction? If so, each interstellar object is not just a traveler but a fragment of tragedy. They may be records of violence written across time, testimonies to the fragility of planetary systems. The terror of such realization lies in its reflection. If other systems cast off their dead fragments into the void, what of our own? Someday when the sun swells into a red giant, Earth itself may be shattered, reduced to fragments cast across the galaxy. Some pieces may drift outward for billions of years, wandering through the orbits of stars not yet born, to other civilizations, far in the future. Those shards would appear as mysterious visitors, just as Oumuamua appeared to us. Yet not all speculation was catastrophic. Some turned to possibility. If interstellar space is filled with wandering matter, then it is also filled with opportunity. These objects could carry organics, the building blocks of life flung from system to system, like seeds scattered by cosmic winds. Perhaps panspermia is not only possible, but inevitable. Life may spread not as a solitary spark, but as embers drifting from countless fires, carried by shards that move endlessly through the galaxy. Still, another idea lurked at the margins, bold and unsettling. What if some of these objects are not natural at all? Oumuamua's unexplained acceleration and unusual shape left the door ajar. Could some of the countless wanderers be artificial ancient probes, sails, or fragments of technology cast adrift when their makers were long gone? If civilizations rise and fall across cosmic time, their artifacts might outlast them. Drifting for eons, they would pass through systems like ours, silent echoes of intelligence that no longer exists. The philosophical shock was profound. For centuries, humanity imagined the stars as distant, unreachable, their silence a barrier against intrusion. But the interstellar objects told another story. The universe is closer than it appears. It presses against us, its fragments slipping through our skies, its histories brushing past Earth. The emptiness is less empty. The night is more crowded. And with each new detection, the distance between here and out there feels thinner. To the scientific community, the discoveries became a call to urgency. Instruments must grow sharper, surveys more complete. The next visitor might carry answers to the questions left unresolved. Could a future mission intercept one, capturing its secrets before it vanishes into the dark? Plans began to form concepts for spacecraft that could lie in wait, ready to launch when the next interstellar traveler is found. The idea is daunting, for these objects move at tremendous speed, but the potential reward is extraordinary. To touch a piece of another star system, to analyze its chemistry in the lab, would be to hold in human hands a fragment of the galaxy's wider story. Until then, the evidence is gathered from afar. Faint light curves, spectra stretched thin by distance, trajectories mapped against the stars. Each measurement is fragile, yet together they weave a narrative of escalation. It's a narrative that says humanity's neighborhood is not a walled garden, but a crossroads. The mystery deepens with every new detection. The question is no longer whether interstellar objects exist. It is how many and what they truly are. Debris of planets, shards of comets, relics of technology, seeds of life, or fragments of catastrophe. Each possibility is both inspiring and terrifying. The story that began with a faint point of light in 2017 has become something larger. Not a single anomaly, but a revelation. The galaxy is not silent. It is speaking through its wanderers. And the more we listen, the stranger. The more crowded, the more intimate the universe begins to feel. In the wake of discovery comes the harder work, the struggle to explain what has been seen. Oumuamua was more than a wandering fragment. It was a challenge. Its form, its motion, its silence broke expectations, leaving scientists with possibilities that stretched from the familiar to the extraordinary. In the years since its passing, theories have multiplied like echoes in a canyon, each reflecting a different vision of what the first interstellar visitor might truly have been. The most cautious minds turned first to natural explanations. Perhaps they argued Oumuamua was debris, a shard torn from the crust of a planet in some distant system, flung outward by a catastrophic collision. Just as Earth once collided with a Mars-sized body to create the Moon, so too might alien. Worlds have shattered, scattering fragments into interstellar space. Over millions of years, those shards would drift outward, losing memory of their origin. Until chance brought one into our skies, others suggested an origin less violent, but equally ancient. During the birth of planetary systems, countless small bodies are cast adrift. See planetesimals, rocky asteroids, protocomets. Most are swept into stable orbits, but many are ejected entirely. Over the history of the galaxy, this process would populate interstellar space with unimaginable numbers of wanderers. By this logic, Oumuamua was not a rare anomaly, but a representative of a vast and unseen population. Yet this explanation faltered when the details of the object were considered. Its shape, inferred from brightness variations, seemed extreme, elongated or flattened beyond what collisions typically produce. More troubling still was the acceleration. As it sped away from the sun, it moved slightly faster than gravity alone could dictate. Comets achieve such motion through outgassing, jets of vapor venting from their surfaces. But Oumuamua released no visible gas, no dust, no signature at all. The silence in its spectra was as telling as the light in its path. This silence inspired a different natural hypothesis. Some researchers proposed that Oumuamua might be composed of frozen hydrogen, a hydrogen iceberg born in the cold nurseries of giant molecular clouds, could sublimate invisibly, its gases dissipating without leaving detectable traces. Loss of hydrogen would create thrust, explaining the acceleration. But this idea met resistance. Hydrogen is fragile in cosmic terms. It evaporates quickly under starlight, and the journey from one system to another could take millions of years. Could such an iceberg survive the trek intact? Gregory Laughlin of Yale argued that it was unlikely. Hydrogen, he reasoned, would vanish too soon. Long before Oumuamua could cross interstellar distances, another proposal centered on nitrogen ice. Pluto and similar worlds bear surfaces rich in frozen nitrogen. Fragment chipped from such a body might explain both the shape and the behavior of Oumuamua. As nitrogen sublimated, it could provide the necessary thrust without visible signatures. This theory suggested that Oumuamua was not unique, but part of a broader population of icy fragments chipped from countless exoplutos. Yet even here, difficulties lingered. The required abundance of nitrogen icebergs seemed implausibly high. Account for even one detection, the galaxy would need to produce them in staggering numbers. More than models of planetary systems could comfortably support. As natural explanations strained under the weight of evidence, more exotic speculations gained attention. Harvard astronomer Avi Loeb advanced the boldest that Oumuamua was not natural at all, but artificial. In his view, its thin, sheet-like geometry and unexplained acceleration pointed toward a solar sail, a craft designed to ride on starlight, Perhaps it was once part of a larger probe, or perhaps it was simply debris drifting without guidance. But if true, it would represent the first evidence of extraterrestrial technology, a message not written in language, but in material passing silently through our system. Loeb's proposal sparked controversy. Many dismissed it as premature, a leap too far without stronger evidence. The principle of scientific conservatism held sway. Extraordinary claims demand extraordinary proof, yet others defended the value of the question itself. If humanity encounters anomalies, should it not keep the possibility of intelligence on the table, even if the odds are low? In a universe as old and vast as ours, civilizations may rise and fall, leaving behind artifacts that wander long after their makers are gone. To ignore the possibility entirely would be to blind ourselves to one of the most profound discoveries imaginable, beyond solar sails. Other speculations wandered even farther from convention. Some envisioned Oumuamua as a lurker, an ancient probe stationed in interstellar space waiting silently for eons. Not an emissary actively communicating, but a sentinel, positioned in the dark to watch. If advanced civilizations explored the galaxy, they might have seeded it with such devices, passive and patient, awaiting discovery. The thought is both haunting and exhilarating, a universe filled not only with natural debris, but with dormant eyes, watching unseen. Still more speculative were theories that reached into the frontiers of physics. Some asked if Oumuamua could be a fragment of exotic matter, a relic of phenomena beyond ordinary cosmology. Could it be debris from a false vacuum, shed in the early moments of the universe? Could it be a shard of multiverse interactions, matter from another cosmic domain drifting through ours? These ideas remain firmly in the realm of speculation, without observational support. Yet their very existence reflects the openness that Oumuamua forced upon science. When confronted with the unknown, even the boldest possibilities must be weighed, however tentatively. Against this storm of theories came the sobering weight of Three-Eye Atlas. Unlike Oumuamua, Atlas bore the hallmarks of a comet. It displayed activity, releasing gas and dust. Its behavior aligned more comfortably with known physics, even as its interstellar origin was undeniable. In one sense, Atlas confirmed the natural explanations. Interstellar visitors could indeed be fragments of planetary systems, ejected comets and asteroids drifting for eternity. But in another sense, it complicated the picture. For if some behave as expected and others defy explanation, then the diversity of interstellar objects is greater than we imagined. One mystery may not erase another. Instead, it multiplies the range of possibilities. The debate between natural and exotic explanations remains unresolved, which carries its own weight, its own difficulties, its own allure. Perhaps Oumuamua was a shard of nitrogen ice, as fragile as it was fleeting. Perhaps it was a solar sail, abandoned and tumbling through space. Perhaps it was something stranger still, beyond the categories we have yet imagined. What unites these theories is not certainty, but humility. For the first time, humanity glimpsed visitors from beyond its star, and in doing so, it discovered not answers, but questions. Questions that echo into the depths of science and philosophy alike. Are we glimpsing the routine debris of cosmic evolution, or the artifacts of civilizations unseen? Do these objects carry within them the chemistry of alien worlds, or the fingerprints of technologies long extinguished? The mystery endures, suspended between caution and wonder. Each theory offers a different vision of the universe, from one that is purely natural to one that is populated with intelligence. Each possibility reshapes humanity's sense of place. For if Oumuamua is natural, it reveals the galaxy as a restless sea of fragments, its planetary histories intersecting with ours. If it is artificial, it reveals something greater still, that we are not alone, and that others, long ago, left their traces among the stars. In either case, the universe is no longer distant. It presses closer, carried in the silent passage of interstellar objects. With each new detection, the weight of speculation grows. Theories multiply, questions deepen, and the sky itself becomes a canvas painted with mysteries yet unsolved. The discovery of interstellar wanderers shook astronomy, but with the shock came resolve. If fragments of alien systems can slip through the solar system, then science must be ready. To capture them, to study them, to read their messages before they vanish again into the dark. Humanity now stands at the threshold of a new era, one where its tools must evolve to meet the fleeting nature of cosmic visitors. The eyes of tomorrow are already being built. On a mountaintop in Chile, the Rubin Observatory prepares to awaken. Its mirror spans 8.4 meters, but its power lies not only in size, but in vision. Night after night, it will sweep the southern sky, capturing the entire dome of stars every few days. The cadence of its survey will turn the heavens into a living film, catching movements too subtle or too fast for older instruments. If Oumuamua had passed under its gaze, the discovery would not have been a fleeting accident, but a certainty. The Rubin Observatory will not simply look at the sky. It will listen for change, for the faint signatures of objects racing in from beyond, far above Earth. The James Webb Space Telescope has already taken its place as a sentinel, though designed for the light of the first galaxies. Its sensitivity to faint infrared signatures offers another path. Should another interstellar object appear, Webb can measure its thermal glow, probing surface temperatures, compositions, even outgassing to faint for the eye. Where Oumuamua gave only mystery, Webb could give detail. It could trace the chemistry of alien ice, the mineralogy of foreign rock, or confirm the absence of gases that comets are expected to shed. In the stillness of space, Webb waits for the chance to turn its golden mirrors toward the next messenger. But telescopes alone may not be enough. For fleeting travelers, light carries only fragments of truth. To truly know them, scientists dream of pursuit. Missions have been proposed. Spacecraft designed not for known targets, but for readiness. To lie in wait, silent and prepared, until a messenger is detected. Then, with speed and precision, to launch and chase. Concepts like the European Space Agency's Comet Interceptor hint at this strategy. Though designed to catch pristine comets entering the inner solar system, its philosophy points further. If an interstellar traveler is found with enough warning, such a mission could be diverted, intercepting a visitor from beyond. Others think more boldly still. Breakthrough Starshot, a project that envisions sending gram-scale probes propelled by powerful lasers to a fraction of light speed, reflects the hunger for interstellar reach. Though designed with Alpha Centauri in mind, the same concepts might one day allow a fleet of tiny craft to chase interstellar objects directly, to sail alongside them, to measure them up close, to see their surfaces not as faint points of light, but as alien landscapes revealed in detail, even as astronomy builds its telescopes and plans its spacecraft. Other sciences contribute to the search. Particle physicists study cosmic rays, those high-energy fragments of atoms hurled across interstellar space. In their collisions with detectors, they carry whispers of distant processes, supernova, black holes, galactic fields, and interstellar dust trapped in the high atmosphere or in collectors aboard spacecraft, gives material testimony to alien chemistry. Each grain is a traveler, smaller than a pinhead, yet vast in meaning. Together, they provide a parallel record, complementing the larger visitors that pass as asteroids and comets. Yet the central difficulty remains. These visitors do not wait. They arrive unannounced, move with breathtaking speed, and vanish before instruments can fully adjust. Oumuamua was already leaving when it was first seen. By the time telescopes gathered their best data, it was too far, too faint, forever beyond reach. Borisov, though more comet-like, also sped past, leaving only spectra and images behind. The fleeting nature of interstellar messengers is the greatest obstacle. To capture them requires vigilance, readiness, and above all, speed. The Rubin Observatory promises vigilance. Its automated surveys promise early detection, but readiness must go further. Space agencies now imagine missions held in reserve, able to launch on short notice, chasing the next object before it escapes. The window may be narrow, months, perhaps only weeks. To succeed will require a new architecture of exploration, one that accepts uncertainty yet acts with precision. Beyond the engineering, an interdisciplinary debate unfolds. Astrophysicists analyze orbits, planetary scientists model origins, chemists parse spectra, while philosophers step back to ask what it all means. If the galaxy is filled with wandering debris, what does that say about the fragility of worlds? If some visitors prove artificial, how should humanity understand its place in the cosmic order? These questions do not belong to science alone. They belong to the human story, to the way civilizations see themselves in the vast theater of the universe. The debates are sometimes fierce. Some urge caution, insisting on natural explanations until proven otherwise. Others argue that to dismiss the extraordinary is to blind ourselves to the possibilities the cosmos may offer. The truth may rest in neither extreme, but in openness, a willingness to test, to doubt, to follow evidence wherever it leads. Whether toward the mundane or the profound future, readiness is not only about technology, it is about imagination. Instruments can catch the next visitor. Missions can pursue it. But the meaning of what is found will depend on humanity's capacity to interpret. A shard of alien geology could tell of planetary births beyond imagination. A frozen iceberg could hint at chemistry that seeded distant life. A fragment of technology, should it ever appear, would change history forever. To prepare for these possibilities is not just to build machines, but to cultivate humility. In this way, the search for interstellar objects becomes more than an astronomical quest. It becomes a mirror held up to human civilization. It asks whether humanity is ready to confront evidence that challenges its assumptions, whether it can embrace mysteries without rushing to closure, whether it can stand before the unknown with both skepticism and wonder. Science is building the tools. Rubin will sweep the skies. Webb will peer into the faintest glow. Interceptor missions will stand ready. Particle physics will gather its invisible travelers. And interdisciplinary voices will weave meaning from the data. But the deeper readiness lies in recognition that Earth does not float alone. It moves through a galaxy alive with fragments, with messengers, with questions that fall into our skies unbidden. Each tool, each mission, each debate is part of a larger preparation. To catch the next messenger not as a fleeting point of light, but as a story revealed in full. To meet the unknown, not with shock alone, but with the capacity to listen, to measure, to understand. The scientific tools of today are the instruments of anticipation. The tools of tomorrow may be the instruments of revelation. And when the next interstellar traveler comes, humanity will be waiting, not by chance, but by design, ready to receive what the universe chooses to deliver. Across the silent gulf of space, 3 visitors have passed through our skies. Small, fleeting, and strange, yet heavy with meaning. Oumuamua, Borisov, and Atlas were not just objects to be measured. They were mirrors, reflecting back the fragility of human understanding. For in their motion lies a truth. Humanity stands as a fragile witness on the shore of a vast ocean, watching driftwood float by, wondering what distant storms sent it. Astronomers bent their instruments toward these wanderers, but what they saw was only a fragment of truth, a point of light flickering as it spun, a tail of gas shedding its secrets into the void. A faint spectrum stretched thin across the stars. From these scraps, theories were built, some cautious, some daring, yet the essence remained just out of reach. The meaning was not captured, only hinted. And in that gap between data and understanding lies the human condition itself. Fragile. Beings aware of their limits, yet reaching beyond them. Each interstellar visitor can be seen as a letter, a message written not in ink, but in physics. The shape of its brightness, the curve of its orbit, the chemistry of its light. These are the strokes and syllables of a language older than Earth, a language humanity can only have. As perhaps the letters are fragments of stories torn from books lost forever. Perhaps they are warnings, the ashes of worlds consumed by catastrophe. Or perhaps they are nothing more than cosmic noise, debris scattered without meaning, drifting endlessly through the night. The metaphor stretches further still. What if these are not letters, but seeds? Cast from one system to another, they may carry molecules of life, the precursors of biology. Panspermia is no longer just philosophy, but hypothesis, tested in laboratories where microbes endure radiation, vacuum, and cold. If life can cling to fragments of rock and ice, then each interstellar visitor may be more than geology. It may be potential. An ember of biology waiting for a world to catch it, to let it grow, to write a new chapter in the story of life. But there is another possibility, more sobering. What passes through are not seeds of life, but the remnants of death, shards of planets ripped apart, debris of civilizations that rose and fell long before Earth's continents cooled. If so, then the visitors are not beginnings, but endings. Messages not of hope, but of fragility, reminder that even worlds can perish, leaving only fragments to wander forever. Time stretches over these reflections like an endless horizon. Civilizations may rise, flourish, and collapse, their traces reduced to dust long before another world stirs. The galaxy is ancient, older than humanity can truly comprehend. If intelligence has blossomed elsewhere, it may already have vanished, leaving behind only artifacts drifting without purpose. Oumuamua's acceleration, its unusual form, could it be a relic of such a lost people? If so, then to see it was to glimpse not presence, but absence, a ghost of intelligence that no longer exists. And yet, within that haunting possibility lies a deeper truth. Even if these are fragments of loss, their passage through our skies connects us to a larger story. Earth is not alone. It is one island among countless shores. The ocean that surrounds us is filled with currents carrying driftwood, wreckage, seeds, and perhaps ships. To watch these visitors is to realize that our island is not isolated, but open to contact with the vast and unknowable sea. The image is timeless. Earth, a small world, afloat in darkness. The solar system, a fragile archipelago. The universe, an endless ocean. From that ocean come fragments washing ashore. Sometimes they are splinters, twisted and broken. Sometimes they blaze like comets, shining with volatile light. And sometimes, perhaps they are crafted things, vessels of intention, ships adrift whose makers are long gone. To look upward is to watch the horizon, knowing that more will come. This recognition brings both wonder and unease. If these are mere accidents, then humanity is simply witness to the restless dynamics of galaxies, nothing more than spectators at a cosmic play. But if they are signs, seeds, warnings, relics, or probes, then the stakes are far greater. The visitors may be part of a conversation too vast for us to yet hear. A dialogue written across millions of years, with messages carried not by voices, but by matter itself. In such a vision, humanity's role is precarious. Fragile beings recently arrived trying to interpret a language they did not invent. The visitors are not tailored to us. They are not sent deliberately to our skies. They pass whether or not we notice, whether or not we are ready. To see them is a privilege of timing, a reminder that observation is itself fragile. If telescopes had been weaker, if surveys had not scanned the heavens, their stories would have slipped by unseen, and yet to have seen them at all is a turning point. The illusion of isolation is broken. Stars are no longer distant lights alone. Are sources of fragments that move across our world, carrying with them the weight of cosmic history. The universe presses closer. It breathes upon us. It leaves behind traces in the form of wandering stones. The question lingers at the close of this journey. What, truly, are we witnessing? Random accidents of physics, the routine debris of planetary birth and death, or the first signs of a galactic conversation, messages written not in words but in objects, cast across the stars? The answer may not come soon. It may not come at all. Yet the mystery itself transforms how we see the night. Each visitor is a reminder that the universe is alive with motion, with history, with stories we can barely begin to read. Earth is not alone on its island. The ocean is filled with driftwood, perhaps one day with ships,